Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. In this episode, we will be disassembling the drive unit, the electric motor and gear reducer, out of our 2017 Chevrolet Bolt on the hoist behind me here. Now, this drive unit and electric motor combination is all one piece, unlike the Nissan Leaf that has a drive unit that unbolts from the electric motor. This drive unit is rated at 150 kilowatts, which is 201 horsepower. It is also rated at 360 newton meters of torque, which is roughly 266 foot-pounds of torque. Now, let's talk about torque just a little bit. That torque rating is what the motor itself is capable of producing. That is not the same as the torque that ends up at the wheels of the vehicle. So, for example, the Chevrolet Spark EV, produced by Chevrolet before the Bolt here, actually had an electric motor that produced 540 newton meters of torque. The Bolt EV electric motor only produces 360 newton meters of torque. And so you might be misled into thinking that the Spark EV had more torque. Well, the motor did, but not the torque delivered to the axles that drive the wheels. So the gear reducer right here on the side of this drive unit has an impact on that, because gear reduction is also torque multiplication minus frictional losses. So the Spark EV had a 540 newton meter electric motor, but it only had a 3.15 to 1 gear reduction unit, which resulted in about 1,700 newton meters of torque at the wheels, at the axles. The Bolt EV electric motor produces 360 newton meters of torque, a whole 180 newton meters less of torque from the motor, but it has a 7.0518 to 1 gear reduction through this gear reducer, which multiplies that 360 newton meters of torque by 7.0518, which gives us over 2,500 newton meters of torque at the axles. So there are other electric vehicles out there that are being produced right now that have higher torque, higher motor torque than the Bolt EV. But what would be interesting, and I don't know what their gear ratios are yet, is to see what is the torque actually to the axles. What's the torque to the ground? Because that's what you'll feel when you step on that accelerator pedal. That's the torque to the wheels that makes the vehicle move. The design of this drive unit, this electric motor, it has a peak amperage draw of 400 amps versus 450 amps for the Spark EV, so it uses less current to provide more torque. So it's a more efficient, better design electric motor. The electric motor in this drive unit spins clear up to 8,810 RPM, where the Spark EV only spun up to about 4,500 RPM. And we'll take a look at some differences in the electric motor design and the stator winding design that allowed it to spin at those higher RPMs without the AC losses that typically occur at higher RPM. As mentioned in the previous video on high voltage components of the Chevrolet Bolt, this drive unit uses about 2.9 liters, around 3.1 quarts of Dexron HP fully synthetic base transmission fluid, automatic transmission fluid. It also is cooled by the General Motors Dex Cool 50/50 mix of coolant and deionized water. Okay, let's take a look at the outside of the housing here of this drive unit. The official name or designation of this drive unit by General Motors is the 1ET25. The 1 means it's a 1-speed transaxle. This doesn't shift. E means it's electronically controlled. T means it's a transaxle. And the 25 is a relative torque rating. All right here on the front of the transmission is the actual last 8 digits of the vehicle identification number. And you can see that MMF right there. That is the 3-digit regular production option code, the RPO code, that you can find on the label in the back of the bolt. If you take out the lower compartment carpet and look in what looks like a spare tire tub, there's a label on the driver's side that has a whole bunch of 3-digit codes on it. MMF just means that's which transaxle or transmission this vehicle came with. Okay, right here on the top of the transaxle is the transmission range selector actuator. And this is a brushless DC motor with a gear reducer that actually moves the shift lever to put us into park, reverse, neutral, drive, and low. Now, technically, inside of this drive unit, there's really only park and not park, but there is a position sensor in here called an internal mode switch that will monitor which position the transaxle range selector is in so that the vehicle can act appropriately. For example, the shifter itself on the center console is not directly connected to the drive unit. It's just an input to the computer that controls this actuator. So when we go to the reverse position or the neutral or drive or low, there's a feedback on the internal mode switch electrical connector right here that lets the engine control module, even though this doesn't have an engine, know which gear range you have selected so that it can request the transaxle act appropriately. Also right here by the electrical connector for the internal mode switch is the transmission fill plug. So if you want to put fluid into this transmission, you need a 14mm wrench or socket to take this plug out and put the Dexron HP fluid into the transmission. There are 2 drain plugs on this transmission, one for each side. So there's one down below on each end of the transaxle, the driver's side and the passenger side. There are 2 separate drain plugs to get the fluid out of each side. Now there's only one fluid that goes throughout this entire transaxle, but because of how it's baffled and set up inside, to remove all the fluid you need to remove both plugs. Now speaking of fluid and fluid level, when you drain fluid at whatever the recommended fluid change interval is, or if you're doing service work on the transaxle here and you're adding fluid, you need to know when to stop adding fluid. So on the other side of the transaxle right here is the transaxle fluid level check plug. So the drain plug's right down here, the fluid level check plug's here, the fill plug is on the other side. So you take the fill plug out, you take the fluid level check plug out, and you add fluid until fluid comes out over here, and then you let it sit and stabilize for a minute, add a little bit more, and make sure that fluid comes out to a slow drip. And then the instructions tell us to put both plugs back in and go drive the vehicle until the transmission fluid temperature reaches 35 degrees Celsius or 95 degrees Fahrenheit. And then double check the fluid level again to make sure that comes out at a very slow drip. All right, while we are here on this side of the transaxle, we have an electric motor, an electric pump for the transmission fluid. So there's a big filter we'll see when we take this thing apart down the bottom center of this transaxle. It will pull fluid up from the filter and then put it into what's called the oil sump. So the oil sump is basically just a great big bathtub looking area up here that the pump fills full of fluid, and then there are these little drain channels that fluid drains down to cool the stator windings and lubricate bearings and so on, and we'll see that once we get the cover off. So we have an electric 12 to 14 volt driven electric motor that pumps fluid throughout this transaxle. From what I read, this pump only works when you are in reverse or drive. It does not pump when you're in park or neutral. All right, we have another electrical connector right here. This connector is for the resolver, which measures the angle of rotation, the direction of rotation, and the speed of the electric motor rotor itself. And then there's a transmission fluid temperature sensor that's in the bottom of this transmission case cover here. All of those are accessed electrically through this electrical connector right here. As you may have seen in my other video on high voltage components, we have the air conditioning compressor that bolts up here, and then we have our coolant pipes that go into what's called a coolant sump in the bottom of this transaxle, and we'll see that here in a few minutes. But we have coolant going in, coolant coming back out, and it goes through a series of cooling fins and cooling circuits to absorb heat from the transmission fluid. Right here on the back we have the electrical connection for the three-phase cables that come from the single power inverter module that sits 2 modules above here. 3-phase orange cables come down to drive the electric motor. There's a cover, the cables bolt on, and then there's a cover that holds the cable in place. We have a transmission vent right here. Let's just take that vent off vent tube off while we're here. Now you can see the oil sump area again on the top, and the coolant sump area here in the bottom. All right, there is one additional plug on the side of the case with the electric motor, and there's nothing in the service information to indicate this, but I believe this is a pressure test plug to check the pump output pressure, but I can't find any information on what that fluid pressure should be. Okay, I'm going to be disassembling this transaxle right here on the workbench, but there actually is a special fixture to hold this transaxle and allow you to rotate it and disassemble different pieces of it and still be able to rotate it for convenience. I have this special adapter, as you can see here in this photograph, but the way it's mounted, it's too high and too difficult for me to disassemble in that holding fixture, being in a wheelchair, so the workbench is where I'm going to disassemble it. But I wanted you to know there is a special fixture for that, and I tried it, it just doesn't work for me. By the way, this transaxle weighs about 170 pounds or 77.4 kilograms. Okay, well, we're ready to start disassembly. The first step is to remove this oil pump, the 12-volt powered oil pump. It has 3 bolts right here and a few seals underneath it. As you can see here, there are 2 seals that seal the pump to the transmission case right here. There are 2 bolts that hold the cover over the pump gears themselves. There are no instructions on disassembling this, so I assume we're not supposed to disassemble it, but that's exactly what I like to do, is take things apart I'm not supposed to. As long as I can get them back together and make it work again. Here we go. We've got a Gerotor style oil pump. There's an O-ring right here that needs to fit in this groove to seal. And then the cover just bolts on. Okay, the next thing on the list is to remove the left hand and right hand output shafts that go into our differential side gears in the gear reducer. This is the left hand side, right hand side over there. It calls for a slide hammer and a old pilot bearing removal tool for a manual transmission. So this is the pilot bearing removal tool right here and a slide hammer, and we're supposed to put this up inside and put it into the snap ring groove for the CV shaft and then pop it out. Well, come to find out, the snap ring groove is thinner than the tip of this tool that's supposed to go into it. And I didn't realize that's what the problem was. And I had a hard time getting these output shafts removed. I finally got them out, but once I got them out and got looking at the tool versus what they were supposed to be grabbing, I realized I need to grind these down, make them a little thinner so that they will actually fit into the grooves of the, or for the CV shaft snap rings that are there. So since I've had this entire transaxle apart before and I'll put it all back together, I've removed those snap rings that hold these output shafts in place, so I can just pull them out by hand right now. This big long left-hand output shaft goes right through the center of the rotor of the electric motor itself. It's hollow in the middle, and it has a big heavy-duty bushing right here on the outside with the axle seal, and this is our left-hand output shaft, and then the CV shaft itself plugs into here that goes to the left front hub and bearing assembly and tire and wheel assembly. So there's our left-hand axle shaft. There's a snap ring that fits in that groove right there typically, and I've just removed that snap ring for ease for this demonstration here. Obviously, I'll need to put that back in when I reassemble. So that's the left-hand axle shaft. On the other side, we use the slide hammer again and pull out the right-hand axle shaft. As you can see, this one is much shorter than the other one, and it has a support bearing in the differential case itself that holds it in place, and its own snap ring that I've already removed. And of course an axle seal here on the other side as well. Okay, the next thing on the list is to remove this transaxle case. To remove the case, I've got to take the linkage off and our actuator off, and then we've got these bolts that go all the way around, and then we'll be able to see the gear reduction transfer gear and the final drive ring gear and differential gear set. So I'll take the clip out and lift up for a linkage on the shift actuator, and then take the bolts out. Okay, here's the shift actuator assembly itself. Transmission range selector actuator. Kind of a great big piece. I've seen some of these that are smaller. I'm not sure why this one is so giant. I've never seen one this big, but it obviously does the job of mechanically shifting the transmission range lever, since you have an electronic shifter on your center console. All right, let's take these bolts out of the transmission case. Okay, I've got all the bolts out of the transmission case. Now we can attempt to slide it off. It has a couple of dowel pins that hold it in place. There's a couple of pry points. There's one right back here and another one right here. There we go. I'm going to come in with a plastic mallet here and just tap lightly. There we go. Okay. We can see inside of the transmission case itself, and the only things in here of real interest are the transmission internal mode switch right here. We've got the electrical connector right here, or harness right there, that connects to this outer blue connector that will read which range park reverse neutral low you have selected with your transmission shift lever. And then we have the parking linkage right here. We've got park, reverse, neutral, drive, and low. Now, of course, normally transmission fluid would be pouring out of here of whatever didn't get drained out when you drained it previously, but I've had this apart and cleaned everything up before. We have our ring gear right here and our differential gear set, and notice we have real nice ball bearings here. These bearings, since they're ball bearings instead of tapered roller bearings, have to have end play shims. So there's a special shimming procedure to control the end play of these bearings that we'll have to go through when we reassemble it. So you're supposed to take these shims off and throw them away. Well, and then replace them with new ones when you go back together. I suggest that you take them off and measure them, and then hang on to them because you might need them again. When I took these off previously and measured them, they were almost all identical in the thickness. So there are 6 of these shims for the 6 ball bearings that are in this transaxle. 4 of these shims measured exactly 0.5 millimeter in width. The other 2, one of them measured 1 millimeter in width and the other one measured 0.9 millimeters. So you need to keep track of what thickness shim you had where and write those down so that you'll have an idea of at least what it was before you took it apart. Now, if you're just going back together and you haven't changed any shims or any parts inside, just reuse the old shims. But if you're changing a bearing or any of these internal pieces, you need to go through the special measurement procedure that we'll see when we go back together to determine if these shims are correct. Okay, so there's special shims on each of these bearings. I've measured all of them, written their dimensions on the Ziploc bag here that I keep them in, and we'll refer to those when we go back together. All right, now we just need to remove the counter gear right here and the final drive, ring gear and differential gear set. This is where our short little output shaft plugged in right here, and then our long one came all the way through on the other side. Okay, before we remove these gears, there is an aluminum gasket with a rubber seal embedded into it. The instructions tell us that is not reusable. There's also an oil baffle right down here to channel transmission fluid away from the ring gear to reduce losses as it rotates into it, and to splash oil up into different channels to lubricate the bearings. If we look in this case haft right here, you can almost see what looks like a funnel right there for the fluid to drain back down and lubricate this outer bearing, and a similar one here on this other side for that bearing. So we've got a oil baffle to remove. All right, I've got the oil baffle removed. On the other side of that is our magnet for metallic particles from normal gear wear and other malfunctions. Okay, now we're ready to remove these gears. I'm going to pull out on the counter gear and then pull out on the final drive, and it'll come right out. If you don't pull out on that counter gear first, there's not enough clearance for the final drive unit to clear. So here's our final drive. You can see our open differential gear set inside there. Here's our shim on the other side as well. All right, the instructions tell us that we can, if we want, to remove the park linkage in the internal mode switch. I don't really care about that. That's just regular stuff that you'd see in any other automatic transmission. So let's continue on with things that are unique to the Bolt EV drive unit here, the 1ET25 transaxle. So let's turn the transmission case around, and we'll take off the transmission case cover here on the driver's side. Now the SAE document that details the Bolt EV drive unit here that I told you about in the high voltage component video tells us that the drive unit itself was designed to be serviceable in the vehicle. That's why they have a case, removable case cover on one side and a case cover on the other side for the gear reduction unit. You can leave this center portion with the electric motor in it in the vehicle and just remove one or both case covers to do service work on components inside the case covers, seal replacements, resolver replacements, internal mode switch replacement, and so on. But anyway, we're going to take off this case cover next from the driver's side. All right, this case cover is going to be a little harder to get off than the other one because the rotor that has internal magnets embedded inside of it has now magnetically pulled itself over to the stator because we are no longer centering it inside of the stator itself. And so it pulls it off to the side just a little bit. So there's a pry point right here, and there's a pry point right down here. Another pry point right here. There we go. Okay, so here's our case cover, and it has an aluminum gasket that's not reusable as well. Our case cover has this long transmission filter that's not serviceable without disassembling things, as you can see. It has a temperature sensor down inside of it right there, and then this is our resolver, our serviceable resolver that measures the position, speed, and direction of rotation of the electric motor rotor inside the transaxle here. Let's turn this around. Oh, by the way, down inside of the bearing housing there is a shim for the ball bearing right here on the rotor itself. So we're looking at the stator and the hairpin 6-conductor deep stator design, a unique design. We'll talk about that a little bit more once we get the stator out. We have a lubrication channel right here where fluid is going to drip out of our oil sump and run along and drop down onto the stator windings themselves and cool the stator windings. It also has a drip channel that comes over and goes down to this bearing here to lubricate it. So we've just got an 8mm head bolt holding the filter in place. And as you can see, the filter just has an O-ring seal on the one side, and you can see the pickup filter screen, filter element on the inside. So this is going to reach all the way in up underneath the stator itself to pick up the fluid on the back side of it. And on the back side of it is the inlet of the coolant, so that would be the cooler oil on the back side there. All right, then on the resolver, it just has three 8mm head bolts that hold it in place and one electrical connector. This resolver only bolts in one location. It's not adjustable. It has automatic learn, unlike the older Toyota Prius resolvers that would actually come out of alignment if you unbolted them, and there was no way for you to line them back up. Okay, so here is our resolver. We'll pull back on the connector position assurance clip, depress the tab, and remove the resolver itself. The resolver is a serviceable unit when and if it ever goes bad. But it should never go bad. All right, then the remaining wire harness and the pass-through connector here just goes over to our temperature sensor. Okay, next on the list, we need to remove what is called the center support. This is what supported the driver's side ball bearing of our differential case assembly. Okay, this is our center support. It's held in place with 6 bolts and aligned with 2 dowel pins right there. Now with that removed, there's nothing to stop our transfer gear from sliding out. It's just a tight fit on the bearing in the bore, as it should be. Just pry lightly. Sometimes these will just slide right out and right in, and other times they'll fight you. Here we go. Okay, so here's our transfer gear, its ball bearing and shim. So put that shim over here with the others. Okay, right here in the end of the case, we still have a lubrication channel right here from the oil trough, the oil sump, I mean, right there. And then we have a cover for the 3-phase electrical connector right here as well. And then on the other side, we have that oil distribution channel right here that cools the stator. So we've got to remove that. We are now to the point where we are ready to pull this rotor out. But we just can't grab onto it and pull it out. It has some super strong neodymium magnets, multiple layers in V configuration inside of this stator. You're not going to pull it out by hand, and you sure don't want to come in here and start prying on it. So the only way to get that rotor out of there, if you want to remove it for service, replace a bearing on it, or the gear on the other side, or another bearing, or just replace the rotor itself, for whatever reason, loss of magnetism, a trouble code sets, or whatever, it takes a special tool to pull it out without having it rub on the stator frame itself, and without having it injure you with you trying to pull it out and it's pulling back in with all its magnetic strength. So to get that out, there's a special guide tool that will hold it centered in the stator, and we need to set that up next. And it starts on the other side here. So there's a special tool kit that costs almost $1,000 to center this rotor as you pull it out. I found one on eBay for a little bit less than that, but it's a very expensive tool. But if you want to do service work on this transaxle, you've got to have it. So let's bring in the special tools. Okay, so I brought in the special tools to keep the rotor centered. There's a special spacer with a notch in it to clear that notch right there. It's just going to fit in there just like that. Then there's a plate that bolts on over the top of this to hold it in place. These don't need to be super tight. They're just holding that little spacer in place. So I'll just lightly snug those up. Then there's a sleeve here that's supposed to fit down the center of that rotor. But these sleeves are a little bit too big. I've had to take sandpaper and sand them down to make them fit inside of this rotor. And I don't know if that's because the tools were made for a first design rotor and then they changed it, or if they just made the tools incorrectly. But these tools are from what used to be Kentmore Tools, the special tool supplier for General Motors. It's now Bosch Service Solutions. So Bosch, you may want to take a look at this tool here, the DT52011-1-3, because it doesn't fit. Doesn't center up inside the rotor as well as it should. I've had to sand it down just a little bit, and then I'm able to tap it in a little bit there, but I think that it's supposed to be a tight fit, but it should be able to slide in by hand, I believe. Then we have a guide pin that's going to go through the center of that. Then we have this outer housing that bolts in place to hold the guide pin in place. So the blue sleeve, this one here, because there's one for the other side also, centers the rotor into this plate, and then this sleeve is centered into this plate. So we've now centered the rotor on this side of the stator. So now we need to go to the other side to put additional tools in to get it centered and then pull it up and out. Okay, at this point, if I had the transaxle mounted in that special rotating holding fixture, I would just simply rotate it on its side and get the rest of the tools hooked up. But I'm not able to use that, so I'm just going to put some extra long bolts in this side of the case to hold the case up off of this tool when I tip it over to support it as we pull the rotor out. Okay. So here we go. We're going to tip the whole thing up on its end, just like that. So now we've got clearance for the tool underneath, and we can get the upper tool set up to pull the rotor up and out. All right, while we've got the transaxle tipped on its side, let's take this oil sump cover off and show you what's inside of there. So it's just a big empty trough, and you can see it has 1, 2, 3, 4, 5, 6 holes in it where fluid is going to go out and drip down on other parts inside of the transaxle for stator cooling and for the ball bearing lubrication. The cover itself has that same aluminum gasket that's not reusable. Also, while we have this transaxle on its end, let's turn it over and take the coolant sump off next. Okay. Here's our coolant sump. You can see this pipe right here is where the coolant comes in, and it has to wind back and forth, and then come back out over here. The coolant sump, which is visible from the bottom of the car with the under car cover removed, also has that same aluminum gasket that's not reusable. Why are they not reusable? I don't know. Maybe the aluminum crushes. These, I'm going to see if I can buy replacement gaskets at the local Chevrolet dealer. It seems like I saw a service bulletin saying that all these parts are serviceable now, and it gave the part numbers for them. But if not, none of these are damaged. It only has 35 miles on it. And I'll reuse them and see what happens. Okay, so coolant sump, oil sump. So now we are ready to pull out the rotor assembly. So to pull out the rotor assembly, we have a guide pin that's going to come in and screw into that dowel that had a threaded end on it. All right, so this threaded guide pin did not line up exactly perfect with the guide pin down below. I can't tell if we're just spinning the whole thing. There we go. All right. It's screwed all the way into that alignment dowel from below. Now we have this tool that has 3 holes that go over the holes where these stator bolts are. So we need to remove the stator bolts next. These stator bolts are not reusable. 3 stator bolts. So we put this tool over the top of that. We want to be very careful that we don't damage, pry, lean, or set anything on the stator windings here that could cause damage to them. So we'll get that lined up just like that. Now I'm going to reposition the camera so you can see how tall this next tool is that fits on here. All right, we have 2 clamshell type tools that are going to come in and clamp down over the resolver cam rotor there and this bearing. They're going to go just like that, except I need to split them apart so that I can get the next tool in, which is this big tall piece right here that's going to go over and down into our stator bolt holes. So we've got this threaded shaft, we've got this adapter right here that these little clamshell tools are going to hook into. And then the threaded shaft with a nut on the top of it, we're going to tighten that nut and pull the rotor up out. Okay, so the tricky part of getting this hooked up is getting both of these clamshell tools over this lip right here. So I have to loosen the nut on the top and let it come down. Let me turn this so you can see what's going on. There we go. Okay, so we slide that open, clamp the clamshells around it, put this sleeve over the top of it to lock the clamshell in place, snug up this nut to hold the lock in place. And then from the top here, we start to pull up on the rotor itself. So I'm going to get repositioned, bring my chair up a little higher here so I can reach that nut. It takes quite a bit of turning to pull that out. Okay, here we go. 30mm wrench. We want to turn the nut and prevent the shaft from turning. So I'm just going to hang on down here. As it comes up, those guide pins, the guide dowels, keep it from rubbing on the stator frame. Although there's almost a strange ratcheting sound as I'm pulling this out that makes me think it's barely contacting the stator laminations or the rotor laminations anyway. We'll pull it out and take a look, see if we can see any witness marks. You can see the top of the rotor now is starting to appear. I think we're finally clearing the top of the... Yes, we are. It all of a sudden got real easy to turn the nut, so we no longer have the magnet pulling out or resisting us pulling out. Okay, you can see the entire length of the rotor here. Got another bearing down below it and a gear below that. Now we're supposed to just lift up on this and pull it out. I'm not sure if I'm strong enough. I may have to bring in the engine hoist to pull it out of here, but it's just sitting on these three non-magnetic aluminum poles here, and we've got the weight of the rotor assembly itself. I measured it earlier, but I can't remember what it is at this moment. But let's see if we can lift this up and out. Oh, I cannot. So let me get the engine hoist. We have to lift it up high enough to clear that alignment dowel. So I've got to lift it up probably 4 more inches, 100 millimeters or so. Okay, I've never tried this before with just a lift strap. Let's bring it up. Okay, the lifting, or the tool was getting stuck in one of the holes for the stator bolts. There we go. Okay, here we go. And we've cleared the alignment dowel. So slide the case out of the way here. And we'll let that back down. Oh, let's see how much that weighs. It says it weighs 60 pounds with the tool. The tool's probably 10 pounds of that. Okay, we have to remember that this rotor is highly magnetic, very strong 8-pole magnetic field around this thing. And so we need to keep it away from anything, any metal particles or any tools or anything else that could cause it to receive damage on its laminations here. In looking at the laminations from removing it, I don't see any obvious damage at all there. Let's let this down and take the tool off and just look at the rotor itself. Get the little clamshell pieces out of there. Oh. These tools are iron of some sort, so we got to keep those away from the magnetic field. As you can see, these blue bars are aluminum. They're not sticking to the rotor itself. And then plastic, of course, works great with magnetic fields. So now we've just got our rotor. We've got our drive gear down here. We've got a ball bearing and another ball bearing. There's another shim down inside the case, a bigger diameter shim for this bigger diameter bearing. All right, I'm going to get some wooden blocks to put this in. All right, here's the rotor for the Bolt EV. As you can see, this bearing seems to have some sort of a gray coating on the outer race where this one does not. And on the counter gear bearings, they also have this gray coating. It doesn't say anything about what that gray coating is for. I suspect it's to prevent corrosion from the dissimilar metals with possible induced currents going through them with the the motor running the vehicle going down the road. I've seen this type of coating on universal joints in universal joint caps, bearing caps, in an aluminum drive shaft. The same color. I don't know if it's the same material. But if any of you know what this coating is for, if you'd please put that in the comments below, I'd appreciate that. I'm just speculating. Okay, so we've got the rotor out of the way. This is a serviceable piece. Now, the last piece to remove is the stator assembly itself. And it has 3 special guide pins that go into the stator bolt holes and screw into the transaxle case. And then they're tapered on the top here, and that's to allow you to slide the stator out without it binding inside. So I'll slide that over there, rotate it down. And just pull out lightly. Here it comes. Just like that. So here's the stator for the Chevrolet Bolt EV. If we zoom in close and look at the stator windings, you can actually see there are 1, 2, 3 rows of these hairpin conductors, which means they are 6 conductors deep in this stator. And from what I read in the SAE document on this new improved motor, that helps reduce the AC power losses at the higher motor RPM. A typical stator, like in the previous Chevrolet Volt, it had 2 rows instead of 3, so they were 4 conductors deep in the Chevrolet Volts and 6 conductors deep here. And one of the people that was on the original design team for the Chevrolet Bolt told me that when they designed this electric motor, and it's designed for maximum efficiency and power, that there was no other motor out there that could even match the efficiency of this motor. And they said that they designed this motor to be the next small block Chevrolet, so to say, of powertrains. So the small block Chevrolet was and still is a very popular, very powerful V8 engine, and has been for many, many years. And their intent was to have this motor design, maybe even this drive unit, be in multiple platforms with the same high power, high efficiency motor system. If we look at the other side here of the stator windings, you can see the other end of the hairpin conductors, and then there's a drip channel right here for oil to come out of that oil sump and to drip down and to go down and lubricate the stator windings, because these get really hot. This is the heat source inside of the transmission, and it although it gets hot, it doesn't get as hot as the fluid. Although the fluid gets hot, it doesn't get hot as a normal planetary gear set style automatic transmission. And the cooling system surge tank reservoir cap was only pressurized to 5 psi for this loop of the cooling system. So much lower amounts of heat compared to an internal combustion engine with a torque converter heat generating planetary gear set style automatic transmission. Now, just a couple of things to get wrapped up with this disassembly video, because we will reassemble it showing the special measurements for the shims and everything when we go back together. But one thing I wanted to show you about these electric vehicles is how simple they are. And when I say simple, I don't mean simple design, meaning it was easy to design these. Simplicity is not necessarily easy. But if we look at the number of rotating parts in this entire drive unit, there are basically 3 main rotating parts. We've got the rotor assembly that then turns the counter gear right here, that then turns the final drive. 3 pieces. No clutch packs, no bands, no sprags, no roller clutches, no pistons, none of the hundreds of parts that you would see in a typical automatic transmission, let alone the internal combustion engine that this is replacing. Of course, there are 3 main moving parts, these pieces here, but each one has 2 bearings on it, so there's 6 more pieces, so there's 9 total. And then inside of the differential here, we have 2 side gears and 2 differential pinion gears. So that makes for a total of 13 possible moving parts inside of this drive unit, and only when you're turning corners would the side gears and the differential pinions be rotating at a different speed than the differential case. So a real basic, very reliable system, these electric vehicles. And this one is very efficient. And the design is very compact to where this left-hand output shaft, remember, goes right through the center of the rotor instead of being offset like on the Nissan Leaf and other electric vehicles out there. So congratulations to Chevrolet and the design team. They came up with this amazing and efficient and simplistic EV drive unit, and I think it's absolutely beautiful. So coming up, I hope to shoot a reassembly video with all the measurements for this drive unit, and then we've got all of these parts out, the drive unit, all of the electronics, and our Chevy Bolt back here on the hoist is totally empty under the hood. So we've got to put that all back together and make it work again. Even the battery is out. The whole thing is stripped as far as the powertrain is concerned, and we're going to put that back together and make it work, and hopefully get it converted to a DC fast charge. Thank you for watching.